So when I draw my arrows, I'm drawing the forces. I want to know what force is acting on the box. Weight is acting on the box. So I draw my arrow on the recipient, because all forces are required. Two objects, one is the sender, one is the receiver. Or source and recipient, however you want to word it. The ground is causing the box to fall. The ground is pulling down on the box, that's why it's falling. The ground is pulling down on the box, and so I draw my arrow down on the box. A little W there. But they come in pairs, so there's another arrow I gotta draw. On
ground.
the planet pulls down on the box, so I draw my arrow down on the box. The box pulls up on the ground, and therefore I draw my arrow up on the ground. And there we go, the first official force diagram. Don't worry, we'll let you do box on ground, box on ground. Then we'll actually do an application of like box on ground. We will relate that directly to something else. All right, questions about the first one?
Are we gonna do another one?
Oh yeah, gotta do one other thing first before we do that. Rookie mistakes. Rookie mistake number one. We'll list a yuck sticker next to that one. No man's land. Way too many times. You'd see a problem like this, and you got box, you got ground, and then I'd see some arrows like that. Forces act on objects. They don't act midway between. Don't do that. Now, there are some times where you've got limited space, especially in notes, depending on how much you've done, where I have seen, on a quiz or test, I look at that and I'm going, all right, I guess I know what the person means, but the arrow really should be touching the object. You should extend that. But if you have that one, I'm probably going to guess, okay, that goes here and that goes with this one. Rookie mistake number two. Force on source. In other words, the arrows are backwards. You're drawing the force on what's receiving it. Which way is that object being forced? Well, the box is being forced downwards. So I'm drawing the arrow down on the box. And the rookie mistakes I haven't codified. If you look at old lectures, do them in a different order. It's not something I'm going to ask you to regurgitate. I'm just pointing it out. These are some of the common mistakes that I've seen. I think we're ready. Box on ground. All right, so now I tried to draw the ground level. If it looks like I intended the ground to be level, then yes, it's level. I have never done the game of, what was that, a 2-degree angle? I can't believe you missed that. I don't do that. So if on a quiz or test you're looking at it and going, I'm not sure if you meant this to be level or not, just ask. Usually when it's not level, it's very clearly not level. All right, so first step, I'm going to separate the two objects. and draw them. Because I need room to draw my arrows. Go down our checklist here. Now, I am not claiming the box is in the air anymore. I'm just drawing a box. I'm drawing the ground. I don't have to draw them in the same order. I can draw them in different order because this is just a representation of the box. What are the forces on the box? What are the forces on the ground? Oh, I did leave my half marks off just to indicate more clearly it's ground. So, but I would recommend drawing them in roughly the same orientation. So if the box is above the ground, then I'm drawing my box above the ground here. And that marker is sad. This one. All right, any of these not involved? Yep, all right.
Tension?
So the box is just sitting there, correct?
Yep, just sitting there.
Friction, if it's just sitting there.
Friction is gonna get thrown out, but not just because it's sitting there.
Does there be like tension? Oh, yeah, we did tension? You already got tension, right?
Yeah, tension's out, other is out. The question is, why is friction out? It's not because it's just sitting there.
It's not, parallel to anything, there's no contact.
Oh, no, there's definitely
Oh,
contact
that
there.
one. Oh, but that's
Motion.
not direct force, like nothing's pushing it.
Motion,
You left out a key word.
relative motion,
The other one,
Force?
desired.
desired. There's no desired motion. This ground is level. Which way is that box gonna slide? If this were a frictionless surface, the box is gonna slide one way or another, or not. Level ground is indicating that there's no desire for it to move one way or the other, without additional objects involved. So friction's out because there's no desired motion. So now we're left with these two. Is there a small mass next to a planet? Or something huge? I got one knot over here and a lot of blank close.
Say no.
You got no?
I'm gonna say no.
I'm trying to think how to say that. The ground, generally ground is an indication of,
Okay, that's right.
Something huge.
Yes, that's right.
I don't think it's called ground if it's not. So weight is involved. So which way do I draw my arrow on the box?
Going down.
Because it's being pulled down. It comes in pairs. Where's the other arrow I draw?
On the ground?
Yep, and somebody indicated up. So there's weight. Done. I have only one small object relative to the ground, and so done. And normal force. Do I have contact?
Yeah.
Which way is the normal force acting on the box?
Going down.
The normal force is pulling it down?
Yeah.
Wow. So if I had a box and I had these two forces acting down on it like that, will that box just sit there?
Mm-hmm.
Is it a uh-huh?
No.
I heard a no that time.
If it's pulling it down, it's not gonna just stay there, it's gonna go down.
Yeah, if I have two forces pulling down on something, that's the way it's gonna go. It's gonna accelerate that way.
Oh. Okay.
The normal force is what's holding the box up. The ground, if suddenly there was a hole appeared right below the box,
Then that's
it's gonna fall. So something's holding the box up. That's the normal force.
okay.
And where's the other part? Acting on?
The ground.
Yep. This normal force here, if I put a box onto soft soil, this is the normal force that would leave the impression. That's the force that would cause when you pick it up, you can see, oh, there was a box sitting there. That's this force causing that. Questions before I talk about rookie mistake number 3? Like,
Okay, so we do tests and things, are you gonna make us draw out that diagram, or can we just not draw out all of that?
there will be a complex force diagram problem. We're working our way towards an example of one.
Okay.
And on that one, I separate the objects for you.
Okay.
So you're just drawing the arrows and labeling them.
But normally it looks like just the box on the ground.
Yeah, this is the force diagram associated with box on ground.
Okay.
Box on level ground, if, for more detail. Alright, so rookie mistake number 3. Not enough space. Seen way too many times. They're doing the force diagram, they don't go to where the things are separated, they leave it like this, and they go, well, I got weight acting down here, I got weight acting up there, and I got normal force here, and I got a normal force there. Yeah, Mr. Yuck sticker. Something like that. Give yourself space, you're trying to tell me that you know what you're talking about, so I need to know what forces are acting on which object, so if you cram it into a tiny space like that, I have no idea. With another class, I gave them a problem, and I gave them the separated diagram, and some people still drew it on the small diagram, as opposed to turning the page where I had all that space. All right, one other thing I need to talk, I want to mention here is the free body diagram. If you look at another source, if you look at other textbooks, they have something which is usually called the free body diagram, and it's very similar to what we are doing here. There is a difference, and I'll explain why I do it differently. The free body diagram is you just draw a dot and you write box next to it, and then you have normal force acting up and weight acting down, and then you have ground with weight acting up and normal force acting down. The free body diagram basically takes the object and reduces it down to a single point. And you look at the forces that way. One, by drawing objects, by drawing the shapes that look like what they are, so by having ground here and a box, I don't have to label them. But also, once we get to chapter 8, where the force is applied matters. And so this is sort of preparation for that. Up until then, not a whole lot of issue if you want to reduce it down to a point as opposed to drawing out a box, but please make sure you label what it is if you're going to do that. But again, once you get to chapter 8, where the force is applied matters, and so this sets up much nicer for where a force is applied. All right, questions before we do box on ground? We're going to introduce one new thing. I'm going to call this A and B. What is the first step after you've drawn the picture?
Aftertown? Aftertown?
Okay, we could do that. Not what I was thinking, but sure. Was
Draw another one?
draw another one?
It's like drawing, Like separately or something?
There we go, draw the objects separately. Make sure I've got room. All right. And now what can we eliminate?
Tension.
Guess we can go ahead and remove, friction as well.
Do we always eliminate all this? Oh, no, we don't, correct?
Yeah, not always.
Oh.
On the test level problem, I don't think maybe on one of them I actually had an other, but usually not. I should say, on the test level complex force diagram problem.
How about other?
Oh, I guess that's what Toya just said. Sorry. Yep, others gone. So we're about to just weight and normal force, just like before. So let's do weight. I always find weight to be the simplest, at least the way mine works. The way my mind works. Which way is weight acting on A? Yeah, I hope it's down, towards the center of the planet. Where's the other part of that pair?
Ground.
Yes. Rookie mistake number 4. Drawing that force on the other small object. Weight is between the small object and the huge object. Four. All right. Anything else have weight?
So we're gonna add B probably.
Sorry,
So
Tony?
it does have weight, right?
Which does?
B,
Yes, it does. Which way is it acting on B?
going down.
And where's the other part of that pair? Acting. Now, there is a mistake in what I've done here, and I did this deliberately. Rookie mistake number 5 is what I've done right here. What's wrong?
Shouldn't they be lined up, the arrows, or is that okay?
No, they don't have to be.
There shouldn't be 2 weights on the ground.
You say there should not be?
Oh, wait, no, it's in pairs.
Yes. 2 small objects, I've got 2 pairs. That's not the problem.
B should be acting up on A.
No. Not with weight.
There's something to do with how you drew the box. So on the one over there, it's a little, like your one corner's cut off.
Oh, yeah,
I think that was
that's
it.
artistic interpretation.
Okay, I'm being honest with you, I drew it the exact same way, cause I thought it had something to do with the problem. with the
No,
box.
no, I almost commented on that one. No, that was just,
Okay.
I was trying to draw a rectangle and I apparently could not.
Sorry about that.
There might be other problems. I mean, it depends on how complex we want to make it, but it is possible that could have been introduced as an issue, but that was not.
Okay.
All right.
Oh,
So,
well, you should have 2 lines of weight going down on B
why?
from the box on top of it.
The box on top of it, if anything, is pulling up, would be pulling up on box B. All right, so let's first talk about that one.
I see what you're saying.
Before I talk about gravitational forces between any 2 objects with mass, I'm assuming box A and box B both have mass. I could put them on a balance and I would get some reading. there is technically a gravitational force between them. If you wanna take that into account, you would draw arrows like that. That force is so incredibly tiny that we ignore it. You're designing a bridge, you ignore it. Things that where there's, safety is critical, you still ignore that, because that force between these two boxes is tiny compared to the weight. The force between me and the table right there, we'll eventually calculate it, but it's only order of 10 to the negative 20th or worse. No, actually, I think it is worse. Newtons, whereas between me and the ground is around 1,000 newtons. So the forces between this object and that object, we're ignoring. The gravitational force, I should say. So we still haven't gotten back to what the problem is. And it has something to do with the labels.
Is it that you drew on the labels?
That have drawn the labels?
It says no drawing, the arrows.
There's nothing wrong with the arrows.
Okay.
I mean, in terms of what communication. There's something wrong with the label of the arrows.
Do you have to specify which forces come from which object?
Yes. If this were accurate, we were saying box A and box B have the exact same weight, because we labeled them the exact same. Unless that's given in a problem, we need a subscript here. A, and B, and B. So rookie mistake number 5. We're getting subscripts. In the complex diagram, I have seen way too many students not do a single subscript, indicating the difference between all the weights and all the normal forces and all the tensions and so forth. I generally get full credit for the first one, and then I take a deduction off for all the others. You can get away with not labeling one of the pairs, but you can't get away with not labeling any of them. If I've got more than one object here. I got 2 weights, 2 separate weights here. I need to somehow indicate that they are different. Now, I picked A and B just to match the object there, but you don't have to. Some students, when they get to it, they use a subscript, which the first one they do is W sub 1, the next one is W sub 2, the next one is W sub 3.